Great. Okay, this is a 40 minutes one. Okay, so I will start right now. The recording is in progress. Yeah, thank you so much, guys, for everything. Sorry for the delay, some technical issues. But yeah, let's just get started right now. We are going to share this on YouTube after this as well. So let me just share my screen. Oh, and let me just share this here as well. Okay. Perfect. Okay, so I will just start right now. So welcome to the workshop with Code Africa. So I'm Santiago and Yinka. He's the dev rep FLEEK. I'm going to be kind of really quick. I want to really thanks to all the different organizations involved in this, especially to Code Africa. And then you can see the other ones from Kenya, Uganda, Nigeria, and Ghana. So this is what we are going to learn today. We are going to learn Web3.js to deploy contracts, to interact with contracts. We are going to deploy a contract in the Sequoia network, and we are going to deploy the front end of a dApp on FLEEK. This is what we need for today. We need to have VS Code. It would be nice if you have the Solidity language and theme on the VS Code extension. Then we need Node.js, MetaMask, and testnet tokens. This is what we are going to cover today. I will actually skip the first step, the first message contract, and then I will just go directly into the second one. So we are going to write a buy me a coffee contract. We are going to write the contract from scratch. We are going to deploy this contract to the Sequoia testnet. We are going to connect MetaMask using Web3.js to interact with the dApp. And then at the end, we are going to deploy this dApp into FLEEK. So let me just get started with some Solidity. I'm going to share the presentation, but I'm not going to cover all this kind of theory. But this is basically a structure of a smart contract, Solidity compiler here. Then we will have the state variables, the events. We don't need the events for today. Then we will have a constructor. A constructor is basically a function that can be executed only one time when you deploy the smart contract. Remix ID, which is a great platform environment to interact, deploy, and test smart contracts. So remix.ethereum.org. This is how we can deploy a smart contract. We just go really quick to Remix. Oh, Yinka, can you make sure that this? Oh yeah, this was already shared in the YouTube. That's fine. The YouTube comments. That's fine.
Yeah.
So how we select a contract, for example, this one, and then we can come to Solidity compiler, and then we just click and compile, and that's how we compile a smart contract. And then if we want to deploy the smart contract, we just need to come here to deploy and run transactions. And then we can choose the smart contract. This is not compiling yet, so let's choose another one. This one. Okay, compiles. And then to deploy a smart contract in the Remix virtual machine, we just click here in deploy. And then we are ready to kind of use the functions of the smart contract from here. In this case, this only has two functions. This storage smart contract that comes by default. One that is store, that you can store a number. It will receive a number as a parameter. And the other one that is retrieve, that is just to kind of get the current number. So if we check if we store a number, let's just store the 77. And then we retrieve the number. We have the 77 here. And if we do 78 and we retrieve, we have the 78. Perfect. So this is Remix ID. It's really useful for you to getting started writing a smart contracts. We are going to use it today as well. All really like in detail, but we have basically the same as other programming languages like Booleans, integers, bytes, strings, arrays, structs, and addresses. The address is like a typical one from Solidity because we have addresses in Ethereum, and then you can explore more here. I will share the slides after this as well. Oh yeah. You haven't connected with your audio. Oh no, that was on me. Yeah, no, that's fine. Yeah. Okay, perfect. Solidity global variables. Some of the global variables that we have in Solidity, we have message.sender, which is the wallet that is calling a transaction. Message.value is when you send value in a transaction, so you can get this value from the transaction. You have different things that we can look at the block. So you can also check more global variables here. Then we also have the address this. If we want to get the address of the current smart contract, we can use this. And then the balance of the current smart contract will be this address parentheses this dot balance. We are going to use these ones today. For function types, I actually will not really cover this, but we have, let's say, two main types of functions. One that will write data in a smart contract and one that will retrieve data from the smart contract. So yeah, we have basically just to know. Function visibility, today we're going to cover only external functions, which is the most important, but then we also have public, private, internal. Block explorers, we are going to use tipolia.etherscan.io, so we can see when we deploy a smart contract, when we send transactions, we can explore everything there. Okay, and this is basically how everything will look when we have the final app. We'll have the React app. Then this React app will use Web3.js in the front end. This will connect to a RPC endpoint, can be QuickNode, Alchemy, or can we talk to a blockchain node, and we'll execute the transaction, or we'll return the data that you want to retrieve from the blockchain. Okay, and now let's write, let me just jump into the Remix to write this smart contract. So let's write a buy me a coffee smart contract. What we need to have for this smart contract is basically a state variable that will be a owner of the contract. In this case, will be my wallet. We are going to have a writing function that will be a function that can receive funds. So if someone wants to send funds to the smart contract, this is the function that they need to call. We'll also have the function withdraw. This withdraw function will be to withdraw the call by the owner. So we don't kind of allow someone else, an external party, to come and withdraw the funds from the contract. And another reading function that will be to get the current balance of the contract. So yeah, for those who don't know what is a buy me a coffee contract, is basically getting donations. It's just basically a contract that will receive funds, and then only my wallet, Santiago's wallet, will be able to withdraw the funds from this contract. So let's just go to Remix ID. Perfect. If you have any questions, like, feel free to also put it in the comments, or just, so if you go to Remix ID, you will see something like this default workspace. And then you will see these contracts by default, the storage, the owner, the ballot. But let's create a new contract by clicking here and create a new file. And then I will call it buy me a coffee.sol. Okay, and then what we need to do first is to put the license. So you can just come here and copy this license. Can be, that doesn't really matter, but let me just put this. I will just put the MIT one. It'll be kind of easy to read. Then the Solidity compiler. In this case, I'm going to use 0.8.0. And then we just need the keyword contract, and then we need to put a name to this contract, which will be, let's say, coffee. And then we just open this compiles. This takes a while sometimes. It's compiling 0.80. Okay. It works.
Discuss the network.
Please, if you're not
Can you mute her?
please mute your microphone. Can you please mute your microphone? Please kindly mute your microphone. Jimmy, can you mute your microphone, please? Abdullahi, can you please mute your microphone? Thank you.
Okay, perfect. I think that's great. Okay, so now we just have this. What we need to do now is to write the state variables. Remember that we have state variables. Oops. Okay. We'll have the variables, then we will have the constructor, and then we will have the functions. We'll be writing functions and then reading functions. So for the state variable, the only state variable that we are having in this case will be the address. So we just need to put here the keyword address. Then we can put a name to this variable that can be, let's say, owner, which is like a really common pattern in smart contracts to call it owner. Okay, and then we have this state variable. Then we will need a constructor. Remember that the constructor is a function that will be called only once. So this goes by typing the keyword constructor. And then we can put here, what I'm going to put in the constructor is basically we are going to set up this address of the owner, which will be my address. So what we can do to set up this is we need to send this parameter like that. And then we need to set up the owner with this underscore owner that is coming into the smart contract. We can also put message.sender. And that means that the address that is deploying the smart contract will be the owner like automatically. But I will just put like owner like this to make it kind of easier to understand. If you have any questions, feel free to put in the chat. Okay, and after that, we external. And something important with this donate function, we need another keyword that is called payable, because this function will receive ether, right? So if you have a function that it will not receive ether, so we can just put like, for example, withdraw, and then it can be just external. And this function can be called by anyone, but it will not receive funds. So this is really important to have this external payable keyword. And if we want that our smart contract receives funds, we also need to put, this is just by default, by the standards of Ethereum, we need to add this little receive external payable here. We just need to add this. Add this as a standard to receive funds. Perfect. So far we have the owner, which is the state variable that will be set up in the constructor. We have this receive external payable that is just by default. That will go in all the smart contracts that receive funds. We'll have this keyword everywhere in all the smart contracts, sorry. And then we have these functions that we need to implement. And we will have this function to get the balance of the contract, which will be external. But because this is a reading function, that means that this function is not changing the state or modifying the state variable of the contract. This will have the keyword view returns, and this is returning at UN 256 because that will be the balance. And then we can return, in this case, the address, this dot balance. So this function is basically returning the balance of the smart contract. Now we need to implement this too. So for the donate function, what we need to do is first we need to get this contract. So we can say payable is, let's say, let me just put here the address, this contract. So in what I'm doing here right now is just getting the address of the smart contract. So get the address of here. So by using the keyword address this, I'm getting the address of the smart contract, and I'm storing this in this variable, which is called this underscore contract. And then the second step that we need to do is to transfer, put here, transfer funds to this contract. So to transfer the funds, what we need to do is call this a smart contract. We need to use the word payable. So every time that we are transferring funds to an address, it can be a wallet or a smart contract. We always need to use the keyword payable. And then we just put dot transfer and then the message dot value. So what's happening here is we are kind of saying, please transfer this value that is being sent in this function to this contract, which is the correct address is here, but just to make it kind of easier to understand, like more readable, I put it like this. But yeah, we can also skip this one, which will be even better because we have less lines of code. But yeah, for this workshop, let's just keep it like that. So this function is basically done. Now the smart contract is able to receive the funds. Now we need to implement the withdraw function. If we don't implement the withdraw function and the smart contract receives funds, then the funds will get stuck in this smart contract forever. So what we need to do is let's fetch the balance of the contract. So to do this, what we need to do is let's create like a current balance variable. This is a UN256 because it's a number. And then we just put it here at. Oh, okay. I'm in mute. Yeah, perfect. I was mute. Perfect. So what we just need to get the balance of this smart contract by typing address this dot balance. I'm storing the balance of the smart contract in this variable, which is current balance. And then the second thing that we need to do is to transfer the funds to the owner. In this case, will be my wallet or the wallet that we set up in this state variable. So what we need to do here is just to write basically the same that we have here. In the donate, we are transferring the funds to this smart contract, but then in the withdraw, we are transferring the funds to the owner of the smart contract. So the keyword payable, and then we will put owner, because it will be my address. So payable owner, then dot transfer to transfer the funds. And then we need to specify how much like are we sending to this owner, right? So we can use this current balance that we have here like that. So yeah, we're basically saying, please transfer to the owner, which is a payable address, this amount, which is the current balance. If there is like any questions, feel free to put it in the comments right now, because it's kind of important that we understand like the whole concept of the smart contract, the functions. So just to recap what we have here, we have the license in the beginning, which is a requirement for all the smart contracts. Then we have the compiler version. I'm using 0.8, but you can use any version, or you can also use a range of versions as well. The name of the contract, which I called coffee. We have a state variable, which is the owner that we are setting up in the constructor. Remember that the constructor is a function that will be only called once in the deployment phase. So I'm sending the owner of the contract as a parameter in the constructor. Then we have two writing functions, one function that will receive the funds. So it's called donate, one function that we will withdraw the funds and will transfer the funds to the owner. And then the reading function, which is get balance, that will just show the current balance of the smart contract. And then this receive is just by default because the smart contract is receiving funds. Is everything clear? Someone has like any questions right now? Yeah, I guess it's fine. Yeah, perfect. So now what we can do, the next step can be to test the smart contract. We can deploy it using Remix virtual machine. So to do this, remember that first we need to compile the smart contract. You can just check this checkbox of auto compile. Then it will just compile every time that you write a line or a character. Then we go here to deploy and run transactions. And once we are here, we have different environments that we can choose. For now, let's just put a Remix virtual machine. You can choose any of these like places. Let's use Cancun. Then you will have like 15 accounts with a fake ether. This is just like, we can choose the different smart contracts that we have. In this case, I only have the coffee contract here. Have a comment. Oh, okay, Cienco. That's a good question. We have some time. I can kind of tell you what to answer your question. So you say that, let's say, for example, I have a project to transfer crypto from one wallet to another. Okay, so what you need to do is transfer wallet to another. Let's say transfer funds. So I'm going to show you a function that will help you to transfer funds from a wallet to another. So basically what you need to do is you need to write payable, let's say address 1, and then transfer to address 2. Sorry, this is the amount. And then here we will have the amount. So in this case, what you are doing from this smart contract, right? So that's basically what you can do with the smart contract, like sending funds from the smart contract to the address 1. And then if you want to send funds to another wallet, then you just need to change the address here and so on. And that's how you can send funds from the smart contract to a wallet, to an address. But if you want to send funds from a wallet to another wallet, so then you can just use MetaMask. And then I don't know if you can see my MetaMask, Yinka, if I open
Yes,
MetaMask,
I can see a
it?
MetaMask. I think, yeah.
Oh, okay, perfect.
Sharing
So if you want to send,
screen.
perfect. If you want to send funds from one account to another one, so in this case, I'm sending funds from Zurich to account 1. So yeah, just as we are going to share the slides as well. With all the code is also there in the slides, so it's easier. I also created a GitHub repo with all the code, so it will be easier to follow. So Cienco, just to answer your question, I can use MetaMask and then I can send, let's say, 0.1 ETH from one account to another account, and then this is how you do it, right? So this is how you do it. So in this case, payable, then the address that you want to send funds, and then transfer. And then, yeah, that's how you can do it from here. Perfect. So now let's deploy this smart contract. Remember, first for testing, and then we are going to use Web3.js to deploy it in the testnet. Yes. In this case, if we implement the sending funds from the smart contract will be the one sending the funds, like signing the transaction. The thing is, the transaction means that someone was calling this function. So let me just show you this again. Let's say that we are sending funds to address 1, right? So if we are sending funds to address 1, that means that someone was calling this function, which is transfer funds to another. So let's say Santiago is calling this function, but then address 1 is sending the amount. The smart contract is sending the amount to address 1. If you want that like Santiago is sending the value to address 1, what you can do is this. The transfer, let's just call this function something shorter. So if you want that Santiago is sending funds and those funds are going directly to address 1, then what you need to do is this. And what will happen here, let me just put my address here to remove this error. Okay, and then what will happen here, it's the error here. Oh, I just need to. And then what will happen here is when I call this function that is called transfer, actually, let me show you. So it will be easier for you to understand. Let's use this as storage. I will remove all these functions and I will just implement this one. Okay, so what's happening here is I'm going to send funds to this function, which is called transfer. And then this transfer will send funds to this wallet. But let me just choose one of the wallets from here. Let's just send that wallet, the address here as address. So that will be better. Okay, so then we are going to send funds to this address, right? So let me just test it here. I just need to deploy in this Remix virtual machine this smart contract. So I did it. And then if you come here, you can see that we only have this transfer function. And then it's ready because it's a payable function. Then we can, let me just get the second address here. I will copy paste here. Then I will go back to the first one. And then I will send, let's say 90 ETH. So you need to click here in Ether, and then you put 90. And then I click in transfer. And then if you see, now I have 9 Ether here, and then I have 190 here. So that's basically how you can send the funds using the smart contract. Is that clear? Let me know if that part is clear. But the one that is sending the transaction is the wallet, because smart contract will never sign a transaction. Okay, perfect. Okay, that's great. Now let's go back to the buy me a coffee contract. Let me remove this function. Okay, so the constructor will receive an address. So let's say that that address will be this one, the one here, and then we can deploy it as well. Perfect. So I deploy it, and then we can see the smart contract here. We have 3 functions: the get balance. Right now we have 0, the withdraw, and then the donate. Something else that we can do, that was actually something nice to have, is a require. This require is just like a double check that we can do. And then what we need to put here is message.sender equal to owner. Oh, this will be in the withdraw. Message.sender equal to owner. So this means that only the owner, which is set here, can call the withdraw function. Otherwise, anyone will be able to call the smart contract, and that's not great. And then we can put here a string, which can say you are not the owner, in case that someone else that is not the owner is calling this. Perfect. So let's deploy this again. So the address number 1 is the owner, the address that ends in C4. I will send the address here. I will deploy. And then we have the functions here. Now I will select the address number 2. I will put 189 Ether. And then I will click on donate. And then let's see what happened. And then if I click in get balance, then we have 189 Ether. And then we can see that this address number 2 only has 0.9 Ether, right? So if let's say if I choose the last account and I try to call the withdraw function, we'll have this error. Transaction to copy withdraw error. And then we have reason provided by the contract, you are not the owner. Because someone that is not the owner is trying to call this smart contract, is trying to withdraw the funds. But then if I change to the first account, and then I click in withdraw, we can see that now we have 198 ETH, right? And then if we click in get balance, the smart contract is empty. Is everything clear so far with the smart contract? How everything works with Remix? Cienko is also clear for you?
Yeah, looks good.
Perfect. Do some code. Okay, yes, I have understood. Great. So let's create a folder. I will call it like code Africa workshop, the npm init-y. And then if we go here, we open this in the code editor, we will see that we have a package.json. That means that this is a node project already. I also love the Ubuntu interface. Yeah, thank you, David. Then what we need to do is to install Web3.js just by typing npm install Web3. Here in the slides, I'm not going to cover this, but I have here in the slides kind of like a quick explanation of Web3.js, like what you can do with the provider. Also how to interact with wallets and accounts. We are going to see this, but I have like some codes here that you can copy paste as well. Okay, so what we need to have is Web3.js, which is installed here already. So we are ready to go. The first thing that I'm going to do is to write a deployment script. So that will be called deploy.js. The first thing that we need to do is to import the Web3 module by just typing const web3 require or import web3. Then we need to initialize a provider. To initialize a provider, we need a RPC endpoint, and this RPC endpoint can be found in chainlist.org, or you can also go to Alchemy or QuickNote or Infura, and you can get the RPC endpoint, but I will just use Chainlist because it's easier. I will write Sepolia, include testnet, and then I will come here to have a comment here. Where is Sepolia? No, this is Sepolia. I don't find this.
I think
only this whole.
I think it usually skips it if you have it installed, if you have it set up already. Or do you have it set up on
Really?
your
I don't know.
MetaMask?
I don't know. Yeah, so let's just use this RPC that we have here.
Mm.
We have one here. So in this case, I'm just going to use the one that we have in MetaMask. If we come to support.io/v3, so we can just, okay, so, oh yeah, JavaScript. So for JavaScript, we're importing the Web3 module here. DM here. And we are just in a variable that is called Web3 with the W lowercase. And we are initializing a provider by typing new Web3, a little bit more soon, new Web3, and then we need to use one from Sepolia. But if you send one from to Polygon, or if you put one that is for Ethereum, then you will be able to talk to Ethereum. But yeah, in this case, we're talking to Sepolia. Let's just check that this is working. If we're changing or not. And are we changing the Zoom meeting or not?
I think we may have to because there are 4 minutes left. So let's confirm the new link and we can have that on the chat. So everyone else can just join that.
Excuse me, I think everything is good because if everyone goes the same Zoom and you have recording.
Sorry, can you say that again, please?
The recording is ongoing, right? So from the MEMA Africa platform.
Yes.
I think it's
yes,
good to continue done.
Yes, it is. That is, the recording is working fine, but the Zoom meeting is going to expire in 3 minutes. So I think we need to set up a new one. I think Melvin is working on that.
Oh yeah, I will set up a new call. Okay, yeah, so in these 2 minutes, let's just make sure that this is working so far. So what I'm going to do here is just to get the latest block number by using this Web3 instance, then .it, which is like the module. Yeah, we are going to upload all these things, George, in YouTube, so it will be easier to follow. And then the function get block number, and this will retrieve the latest block number of the Sepolia testnet. So let's just run this node deploy. Oh, I missed the await here. Ooh, so we are having an issue. When we have these issues, that's the RPC endpoint. So yeah, we'll look into another RPC. I don't know why. Okay, that's fine. Let's just use this one. Oh, I actually have one here. And this. Okay, we have 1 minute left. That will be fine. Code. And then contract 2. Okay, so I'm going to use this RPC. This is a public RPC that anyone can use. Just it's Sepolia public. Then let's just try this again. Oh, so I'm sure there is an issue with Sepolia right now. Yeah, so we need to change it to Polygon. And then that will work super well. So yeah, that happens. So now let's look here for Mumbai. I'm sure there is like an issue with Sepolia right now. To the Mumbai network. And this is the latest block number in the Mumbai network. The link. That's a good question. For everyone. I will update the Luma event. I will put it in the Luma event. Yeah.
So please check the Luma or check the group chat.